Take a look at part B. Part B here, they want to find the times when the two particles travel in the same direction. I know it's being blocked in the picture there, but I want you to be able to see the board. So we already know when particle P travels with a negative velocity and a positive velocity. So we're just going to take a look at particle Q. Notice they gave me a velocity function for Q. Okay, the velocity function for Q is t squared minus 8t plus 15. So I don't need to take a derivative there. That's already a velocity. I just need to figure out when it's equal to 0 because it changes directions, okay? Remember, when you're on the non-calculator part, this is non-calculator, factoring is going to come and play a lot here. T minus 3 times T minus 5 is going to factor to equal that. So T equals 3 and T equals 5. Those are going to be the two places where the velocities are 0. I'm going to match my timelines up. So I've got a 1 here. I'm going to put a 3 here. And then a 5 over here, and then they both, remember, cut off at 8. I don't know if I'm still on the screen there or not. Yeah, just barely. Anyway, so we just need to test each of these regions. You can test in the original velocity equation, or you can test in the other one. For example, if I put 0 in this function, we get positive 15, which is a positive velocity. Okay, pick something between 3 and 5, like 4. Actually, it might be easier to put a 4 in here. 4 minus 3 is positive. 4 minus 5 is negative. So positive times a negative would end up giving us a negative velocity between 3 and 5. And then put a number between 5 and 8, like 6. 6 minus 3 is positive. 6 minus 5 is positive. That's a positive velocity. Remember, we don't need the actual velocities. We just need to know if they're positive or negative. So anyway, we can compare our two number lines now. And since I lined them up, it should be relatively easy. This one's positive all the way up to 3. This one only starts being positive at 1. Okay, so and actually it's got a 0 velocity at 1, so it's after 1. So when t is greater than 1, and then this one changes to negative at 3, and this one stays positive. So this is positive at 3, well, no, it's between 1 and 3, right? Because this has a 0 velocity at 3. So they're both positive kind of in this range here between 1 and 3. Okay, this one's negative, but then they become positive. This one stays positive forever, and that one's positive again between 5 and 8. They're both positive at 8. So when t is greater than 5, and if it's equal to 8, those are the ranges there, okay? And let's see, I do have a little bit more time. Let's go down and look at the solutions to this. So the scoring for question 1 looked like that. You've got the two intervals there, 2 points out of 9. And then you can go ahead and take a look at the next one here. They did make number lines and match everything up. It looks like you get 2 points for the intervals, and you get a point for the analysis looking at the different velocities there. Notice, by the way, that they make kind of a sentence explanation of what they wrote. So I wouldn't just circle these. I would write a sentence that kind of summarizes what you found, but show all the work that you've done as you go. Okay, so show your equations, show your number lines, and you're going to get the credit. So that's what's going on in part B. Now on to part C.